Okay, girls, so today's lesson we're going to be doing terminating and recurring decimals. And to do this, we have to start doing a little bit of recap on the type of decimals that they exist. So let's look at this. So, okay, so when we're talking about decimals, let's try to remember what type of decimals do we know that there exist. So one type of decimals is, let's say, the normal type, the one that is most common, that is terminating decimals. And terminating decimals maybe are more common in the examples or exercises that we do. So if we do some examples are 0, 3/10, 2500ths, 1,000th. So all those decimals that end, they finish, those are called terminating decimals. Okay, just putting this. Okay, there is another type that is called the recurring decimals or repeating decimals. I think, let me just see, I have it here in my notes. I just want to check if it's called repeating or recurring. Recurring. In your book, they're called recurring decimals. And an example of this one is, for example, when it's 0.3 and then there's a line here. That line, sometimes you see a dot. I usually use a line always in my examples. I'll explain in a minute why, but this dot or this line will mean that it's like 0.3333, and it goes forever. Agree? But it's always at 3. That's why we can write it like this. Another example is, let's say 0.48, and that will be 0.48, 48, 48, 48, forever 48. Okay. The reason why I like to use a line is because you can have sometimes recurrent decimals that are like, for example, 5, 7, and the 1 comes only 1, and from that moment on the 5 and the 7 will be repeating. So the line is very clear to show which are the digits that are being repeated. So that's why I like using always the line. So then you go 0.1, 57, 57, 57, 57, forever and ever and ever. Okay, so that's the second type. The third type are called, this is very original, non-recurring, non-terminating, terminating, and non-recurrent decimals. Basically are those decimals that are none of the previous ones. Okay, and these decimals, I'm just going to write an example. Our are decimals that never end, but they don't have a recurring recurring pattern. It doesn't repeat certain digits a number of times. So an example will be 3.4. And it goes forever and ever and ever and ever. So the digits are always changing. So these digits never are not repeating, they are not following a pattern. So going back to the first lesson, when we talk about family of numbers, these two types, the recurring and the terminating decimals, this bit here, are rational numbers. Why? Because they can be written as a fraction. Let's remember that rational numbers are all numbers that can be written as a fraction. So in the form of a over b. this one below this here are called irrational numbers, and it's not because they're crazy. Irrational, I'm writing so badly. Irrational numbers is not because they're crazy, only because they can, because they cannot be written as a fraction. Okay, so in this unit we are going to be focusing only on rational numbers. So we're going to be focusing only on terminating and recurring decimals. Okay, and we're going to do some examples. Okay, fantastic. So this is what we're covering in this lesson today. Okay, let's do this example. It says, convert the following fractions to decimals. State if the decimal is a recurring decimal or a terminating decimal. Fantastic. So let's just recap and remember that. Thank you. So when we have a fraction, let's remember that it's also another way of writing a division. So 1/5, I'm going to do it on this side over here. So 1/5 is the same as saying 1 divided by 5. Agree? And the way that we do this division is we say how many times 5 goes into 1. It doesn't go any times, and we put a 0 and our decimal place. And then once we have add our decimal place, or our decimal point here, then I can add a 0 underneath. And then I say how many times 5 goes into 10. It goes twice, and I don't have anything left, so it's going to be 2/10 our answer here. Okay, let's do the next one. This is the next one. I'm going to do it with green so that it looks a little bit more clear here. So here I know that I have 4 whole numbers because I have 4 whole numbers and the fraction part is 5/12. That means that if I write that as a decimal, then I know that I have 4 whole numbers, so 4 whole units, so 4 point, and then 5/12 is what is going to be my decimal part. So let's do it here. 5 divided by 12. Okay, so how many times 12 goes into 5? It doesn't go any times. I put my 0 and my decimal point, and I write my 0 here. So 12 into 50, it goes 4 times, 48. Agree? So 4, and then I have 2 remain down. And because I'm after the decimal point, I can put another 0 here. So that's 12 onto 20. That will go once. And then I have an 8 remainder, and then I'm going to go 0. And then it's going to be, let's say, if it's 7, it's 84. So it's 6. 6, and it's going to be 72. So 6 times 12 is 72. So I have a leftover of 8 again, and we can start seeing what pattern is going to happen here. So I put another 0, and that means that I have another 6 here, and 6 times 12 is going to be 8. And we can see that it's happening. It's going to be another 0 again, and it's going to continue forever. So what is happening in here? The 6 is being repeated. Agree? So I'm going to highlight it here. This 6 is being repeated, and it's going to continue happening, that 6 over there. So this is going to continue happening here. So my answer is going to be 4.416, and I put my dash on top to symbolize that this 6 is going to continue repeating. Oh, I forgot to write before that. We had to write if this one was a terminating or a recurrent decimal. This one is a terminating. And the second one is a recurring. Beautiful. Okay, let's do this one. -5/8. So again, I'm not that it's going to be negative. So before I get confused, it's going to be negative. But let's do the operation here. It's going to be 5/8. So we go, how many times does it go? 8 into 5, it doesn't. So it's 0 point and then 50. And then I go is 8 times 7 is 56, times 6 is 42. Yeah. 48. So sometimes I have to do it in Spanish because I forget. So 6 is going to be 40. 6 por 48. It's going to be 48. So take away. So I have 2 left, and then I put my 0. So it's going to go twice for 16, and then 4 leftovers, and I go 0, and then it's going to go 5. And that's exactly because 8 times 5 is 40, so I don't have anything remembered. So the answer is going to be negative 625 thousandths. Wonderful. Now let's go do this one. 2/3. So same thing, we do 2 divided by 3. It doesn't go anytime, so 0, decimal point 20 is going to be 6/18, and then we have another 2 here and a 0. We can see that it's starting a pattern, so it's going to be another 6, and here another 2, and I know that this is going to continue forever. So now I have here the digits are repeating. So this is going to be equal to 0.6. And I write the dash on top to symbolize that this is going to continue forever. Wonderful.